Hello students, welcome to my class. This is Miss Bada here and I will be covering Unit 3 and 4 from paper 304, that is Database Management Systems. Today we shall see certain portion from Unit 4 and here they are. Unit 4 consists of these following topics: the object and object relational database, and here they are: object-oriented database concepts, which consists of object identity, object structure, and type constructors, followed by encapsulation of operation methods and persistence. Then we have type hierarchies and inheritance, object database standards, languages, and design. And we have the object relational and extended database system. And lastly, we have the emerging database technologies and applications. Alright, let us see the first topic. First, we shall see the introduction, that is the history of databases. First, we have the file system, which stores data after process has been created, but then it has ceased to exist. Next type of database, we have the hierarchical or the network system. The characteristics being concurrency, recovery, fast access, and complex structures. Next, we have the relational database, which is still widely used, and it is more reliable, less redundant, more flexible, and has multiple views. However, relational databases tend to exhibit themselves in tabular format or in the form of tables with rows and columns. Lastly, the one that we'll be doing now is the object database management system, which is introduced in the 1990s, and the characteristics of object database are better simulation. It has more on and complex data types, more relationships, single language for database and programming, better versioning, no reconstruction of objects, and other advantages being reuse, inheritance, encapsulation, polymorphism, etc. There are two approaches in this chapter, that is object-oriented model, which we'll be doing later, and which is also being incorporated by the ODMG standard, that is the Object Database Management Group, and it is totally based on pure object-oriented concepts. Next, we have the object relational model, which is an extended relational model with object-oriented concepts. We can say, in other words, that object relational model is an integrated model between relational and object-oriented model. The first approach, the object-oriented model. Here the relations are not the central concepts. Classes and objects are the main concept in object-oriented model. Object-oriented database system concepts have their origin in object-oriented programming languages. We can say, in short, OOPL, and the OODBS has this concept, that is abstract data types, encapsulation. In other words, we can say information hiding. Also consists of methods, class and type hierarchies, inheritance, etc. The object has the following features, that is, it is made up of state or value and behavior or operations. We shall see this in detail later. In object-oriented database system, objects are persistent, that is, objects will still exist even if the program has been terminated. Alright, from a database design perspective, the object-oriented model is a logical model. If you recall, in second semester we have done system design, and in the designing method we have two types of method, that is the logical and then followed by the physical model. And hence the object-oriented model is a logical model like the ER model. Next, essentially an object corresponds to an entity in the ER model, but many issues are missing in the ER model. For example, methods. Alright, let's move on to object identity. What is an object identity? You see, every student in the university will have an ID. Alright, and every ID will, and each and every one of you has got an ID number. So the same with objects in object-oriented database. Each and every object in an object database has to have an object identity. We call it an object identifier. And this object identifier is used to manage inter-object references. Object retains identifier even some or all of the values of variables or definitions of methods change. Right? Even if the value of an object change, let's say a certain attribute, the value of a certain attribute changes, or there is additions of values of variables or definitions of methods are changed, the object identifier, the object will retain its object identifier, and hence the object identifiers are immutable. By immutable we mean it is unable to be changed or to undergo changes. Next, object IDs are not based on physical representation or the storage of object. No matter where the objects are stored or how the objects are stored in a program, object identifier will not change its characteristic, or will not change its unique identifier. The object identity is a stronger notion of identity than in programming language or data models not based on object orientation. However, this concept does not apply to tuples of a relational database. By tuples here, tuple is one type of a type constructor, or we can say one type of object structure, which, and in simple words we can say a records that is represented in the form of rows. Alright, we shall see about that. Some object-oriented models require that everything from simple value to complex object has an object ID. Object identifiers are used to uniquely identify objects. It is stored as a field of an object. It is used to refer to another object. That is, the spouse field of a person object may be the identifier of another person object. And lastly, the object identifier can be system generated, that is built in, which is created by the database itself, or it is externally generated by a user, a developer, or an administrator. Next, we move on to object structure. In object-oriented database system, the state or the current value of a complex object may be constructed from another objects or other values using type constructors. Alright, or we can say in other words, an object structure is totally dependent on the type constructors, or it is influenced by the type constructors. Basic type constructors are atom, tuple, set. It also includes list, bag, and array. And the formal representation of an object is a triple, that is I, C, and V. I here stands for the object identifier, C is a type constructor, and V is the object state or the value. Here are the examples below. See, for the third object, you can say O2. It has an object ID I2, the type constructor being atom, and the value is computer science. Computer science here can stand for department or subject, right? Model allows arbitrary nesting of constructors. That means we can have combination of type constructors. For example, a bag of list of sets of numbers. All right. Graphical representation allow to compare states of two objects for equality. All right. Objects can be compared for their equality. The identical state we call the deep equality, and the equal state, that is shallow equality. All right. The identical state means graph must be identical. All right. So even the object IDs at every level. Whereas the shallow state, the graph structure can be the same, but some nodes have different object identifiers. I will provide the study material for this in the Google Classroom, so you can check from Google Classroom. Next, we'll move on to type constructors. Object definition language that includes type constructors can be used to define object types for a particular database application. Type constructors in ODL are used to define data structures for object-oriented database schema. All right, we can say, as I've mentioned earlier, the structure of data for object-oriented database is totally dependent on the type constructors. All right, let's see the example below. Here we have a type employee, and the type constructor here is tuple. That means the values are represented in tuple format. That means in row. In the first row, we can have the first name in string type, then the last name in string. Salary is float. Hire date is date. And then we also have another field, that is supervisor is employee, and the department. Next we have a date. Another type is date. It is also in tuple form. We have the year as an integer, month integer, and day integer. Another type, department, here it is also represented in tuple form. You have the department name. D name here stands for department name in string, and we have the manager also in tuple format. We have the employee, then start date, location in the form of set or and string employee. All right, that is all for now. We can continue with another topic later, that is type hierarchies and inheritance, in the next video.